The final frontier, as we know, is a region we haven't explored completely, although scientists have made major discoveries in our home galaxy, the Milky Way. Most of these discoveries were made by machines built by the National Aeronautics and Space Administration, and some of these machines have etched their names into the history books. Amongst these machines are Voyager 1 and Voyager 2. Although both these probes have been making discoveries for years, they have finally come in contact with something terrifying in space, which has sent a warning back to the scientists at NASA. What did these space explorers come in contact with, and what effect would it have on everyone living on Earth? Join us as we explore Voyager's terrifying warning that something just made contact in space. Launched in the summer of 1977, the two interstellar probes began to make history by leaving Earth into space. 45 years later, these car-sized probes are still pushing on and making more discoveries for NASA. Contrary to their names, Voyager 2 was the first probe to be launched, while its twin Voyager 1 was launched some weeks later. These space explorers are equipped with a 12-foot antenna mounted on each, and they had just one mission stated for them during their first launch. This mission was to visit the gas giants up in space and to send information about them back home. After they completed their missions, the spacecraft changed course. However, the divergence of these space probes turned out to be an historic achievement as they took advantage of the rare planetary lineup that happened at the time. The spacecraft flew by Jupiter, Saturn, Neptune, and Uranus and took mesmerizing photos, something no other spacecraft has done efficiently. As they took more images, they sent information back to the scientists at NASA who studied them. The probes also discovered the planet's moons and detached enough photos of these moons before sending them back to NASA. By year's end in 1989, the mission was completed, or so scientists thought. Voyager 1 put the icing on the cake by taking a picture of our world in 1990, nicknamed the Pale Blue Dot by astronomer and science communicator Carl Sagan. After these historical pictures were taken, NASA officials decided to send the Voyager 1 towards outer space, where it came in contact with something different. This made the spacecraft send back messages to scientists who were baffled about this discovery. When scientists checked the readout from the attitude, articulation, and control system of the spacecraft, they saw that the spacecraft's movement and orientation were not aligned. This unforeseen development made the team of scientists handling Voyager 1's movement conclude that the spacecraft did not understand its location in space. Scientists assume this since the AACS allows the spacecraft to send data about the environment in which it is located to NASA. With this malfunction, the spacecraft could not send its correct data, thus making it a major concern to the officials. Suzanne Dodd, a project manager who began working at NASA's Jet Propulsion Laboratory in 1984, commented about the spacecraft's malfunction. She said this incident is not exactly a mystery, judging from the current stage of this Voyager mission. She said, "The spacecraft are both 45 years old, far beyond what the mission planners prepared them for." Thinking the issue might also be affecting the twin spacecraft, Voyager 2 was checked for any possible anomalies related to Voyager 1. When Voyager 2 was inspected, tests and data reverted from the spacecraft indicated that its operations were completely normal. After gathering all the data and trying to figure out what went wrong with Voyager 1, scientists discovered that Voyager 1's attitude, articulation, and control system was transmitting randomly generated data. This data needs to explain exactly what is happening on the interstellar probe. There are 3 computer systems on Voyager 1. Of all 3 computer systems, there is one that controls the spacecraft's orientation. The spacecraft's orientation keeps the Voyager's antenna directed towards Earth, so the data keeps returning to NASA. The same computer is also responsible for controlling the spacecraft's thrusters. When scientists checked this data, they saw that the computer's telemetry signals didn't make sense. The signals from the computer were producing either all zeros or the number 377. However, Dodd mentioned that as long as this system anomaly doesn't make the old spacecraft go into safe mode, she said all is still well with the spacecraft. Dodd continued further, saying that if the spacecraft had a major issue, the team would have started experiencing a decline in the signal coming from the spacecraft. There was no decline or degradation, which seemed to be a good sign. The spacecraft was diagnosed, and running the diagnosis comes in 2 parts. The first step was to find out the root of the issue about the spacecraft or to switch the details to some of the backup hardware. Still, one thing was certain about the Voyager spacecraft: despite its current issue, it would continue to be operated. With the steps to solve the spacecraft's issue in space, engineers and scientists at NASA looked into the situation and dived in to solve the problem. The diagnosis results showed that the attitude articulation and control system had been sending telemetry data to an onboard computer that had stopped functioning some years ago. Sending information to a non-functioning computer wasn't good enough, so the computer corrupted the information, leading to all zeros or the number 377 seen at NASA. Having seen the situation, the team of scientists came up with the solutions that would solve the spacecraft's issue and would not pose a risk to its well-being. The scientists then moved by commanding the attitude articulation and control system to continue sending data back to the computer like before. The solution worked as the interstellar probe system returned to its optimal functions and data was sent to the right computer again. Although scientists are yet to unravel why the AACS started to route telemetry data into the wrong computer. Some of the scientists on the team feel that the issue must have been caused by an error from a faulty command generated by another computer on the spacecraft. If this was truly the issue, it would be sure that the problem was coming from a different place on the spacecraft. The team of scientists also believed that this issue would not threaten the long-term health and future of Voyager 1, and they still wouldn't stop until they found out why the invalid data was derived from the spacecraft system. "We're happy to have the telemetry back," Dodd said when she announced the spacecraft's correction. "We'll do a full memory readout of the AACS and assess everything it's been doing. That will help us try to understand the problem that caused the telemetry issue in the first place. So we're cautiously optimistic, but we still have more investigating to do." We have heard from scientists and read in books that our solar system has no boundaries, but the Voyager spacecraft debunked this by coming in contact with one of the boundaries in space. In the 2000s, the spacecraft crossed a region in space known as the termination shock. The termination shock is a region where solar wind particles are slowed below the speed of sound. This results from the pressure from the gas and magnetic fields in interstellar space. The space probes then crossed through the heliopause in the 2020s, the region that sets a boundary between the interstellar wind and the solar wind. Surprisingly, there are other boundaries they came in contact with. Voyager 1 and Voyager 2 were built to run on different energy sources. These nuclear-powered systems have kept them floating and exploring space for the past 45 years. The Voyager space probes are powered by radioisotope thermoelectric generators known as RTGs. The RTGs are what turn heat from the decay of radioactive material into electricity, which powers the Voyager spacecraft. Even though NASA's Voyager 2 was launched before Voyager 1 exited the asteroid belt faster than its twin probe after taking a faster route. It overtook Voyager 2 on December 15, 1977. Voyager 1 started its Jovian imaging mission in April 1978 when it was 165 million miles away from Earth. When scientists studied the images sent back by January 1979 by the spacecraft, they compared it to the Pioneer flybys that took place in 1973 to 1974. The pictures showed Jupiter's atmosphere was more turbulent than the Pioneer flyby images. It also explored the moon of Io, where it took pictures of the moon and sent them back to scientists. The images showed a weird mix of yellow, orange, and brown worlds with at least 8 active volcanoes. These volcanoes were seen to spew materials into space, making it one of the most geologically active planetary bodies in the solar system. The discovery of this planet's components by Voyager 1 suggests the reason for the sulfur and oxygen found in Jovian space. As it continued its exploration, it discovered 2 moons, Thebe and Metis, but that's not all. When the space probe got to Jupiter, it explored the gas giant, its magnetosphere, and its moons more efficiently. The Voyager explored the planet more than the Pioneer spacecraft before it. It saw that Jupiter's atmosphere was more active compared to the records made by Pioneer 10 and 11. This discovery made scientists revisit the earlier atmospheric models, which could not explain the new features. One of the interesting things about Voyager 1's trip to Jupiter was the thin ring found around the planet. This discovery made Jupiter the second known planet to have a ring. Another discovery was on Io. Voyager 1 discovered that Io has extremely active volcanoes. These volcanoes are powered by heat generated by the stretching and relaxation that the moon endures every 42 hours. This happens as its elliptical orbit brings it closer and then further away from Jupiter. This remarkable discovery by Voyager 1 revolutionized scientists' concepts about the moons of outer planets. After studying Jupiter, Voyager 2 used the planet as a springboard to Saturn using the gravity assist technique. The spacecraft took photos of the moons Europa, Callisto, Amalthea, and Io. The images of these moons gave a correct detail of their terrain for the first time. When the spacecraft approached Saturn in 1979, it found 5 new moons. During its flyby, it photographed Saturn's 5 moons, Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. When the moons were studied, all the moons seemed to be composed majorly of water ice. Voyager 1 was the second spacecraft to ever visit Saturn. On its visit, it explored the planet and its rings, moons, and magnetic field, effectively unlike its predecessor, Pioneer 11. The now interstellar probe made all its achievements and met all its set goals except for its photopolarimeter, which didn't operate. The photopolarimeter is one of 11 science experiments conducted by the Voyager spacecraft. It is designed in a way to detect surface and atmospheric chemicals, which prompted its use on Jupiter and its moons. As it moved further in its explorations, the spacecraft found 3 new moons, Prometheus, Pandora, and Atlas. Pandora is the shepherding moon that keeps the F ring well defined, and Atlas is the moon that simply shepherds the A ring. The spacecraft took images of the moons Mimas, Dione, Rhea, Enceladus, and Tethys. These images showed the beautiful structures of Saturn's complex and wonderful ring system and added the G ring to the known list of rings. The most interesting discovery by Voyager 1 has to be Titan, which passed on November 12, 1979 at about 4,000 kilometers. Images taken showed a thick atmosphere that covered the planet's surface, but after snooping around, the spacecraft saw that the moon's atmosphere was made up of 90% nitrogen. The pressure and temperature at Titan's surface were 1.6 atmospheres and minus 292 degrees Fahrenheit, respectively. When scientists studied Titan's atmosphere, results from the planet suggested that it might be the first body in the solar system apart from Earth that had liquid on its surface. The results also indicated the presence of methane, nitrogen, and more complex hydrocarbons on the planet. These discoveries meant that prebiotic chemical reactions were possible on the planet. And then, just like the way Voyager 1 used Jupiter's gravity to help reach Saturn, the spacecraft used a gravity assist at Saturn to help change its course and increase its speed. This gave the spacecraft a trajectory to fly out of our solar system. With 4 instruments operating on Voyager 1 and 5 on Voyager 2, both space probes were given a different purpose. Since their first mission, the spacecraft was tasked with taking note of their environment. This includes measuring the magnetic field strength in the area, the density of plasma around the spacecraft, and the direction of charged particles in the spacecraft's location. The aim of this new mission given to the Voyager space probes is to measure the sun's effects as the space probes venture deeper into space and further away from Earth. With this, scientists and researchers on the Voyager interstellar mission at the Jet Propulsion Laboratory would learn more about interstellar space and how the sun's heliosphere interacts. Since Voyager's launch 45 years ago, the 2 interstellar probes have covered a distance that no other spacecraft has achieved. Voyager 1 is 14.6 billion miles from Earth, while Voyager 2 is 12.1 billion miles away. An unbeaten record was achieved by both spacecraft made by mankind. It is a remarkable coda for their mission, years after the spacecraft completed the main goals that took them to space. Their initial mission was supposed to last 4 years, and now the space probes are still going strong 45 years later. And despite this record achievement, the NASA administration continues to track their journey, and they keep responding by sending information about their environment back to NASA. However, the space probes were given another purpose, embedded in the spacecraft right before their launch. The Voyagers were built to carry along a golden record. This golden record contains a message from Earth, and it is sent in case any alien from beyond the solar system discovers the Voyager and decides to go through it. The golden record is made of metal but looks like vinyl. It was built by a team of notable scientists like Carl Sagan and Frank Drake. The golden record contains several earthly things like music, sounds of nature, messages, and photos. The scientists also gathered instructions on operating the golden record in case it was ever found. This project was added to the Voyager mission so it would tell a story about humanity and what humans envisioned. In the golden record, music of Bach and Chuck Berry were added, including images of families, homes, and technological advancements that scientists have achieved. John Lomberg, a scientist, artist, and designer for the Golden Records team, explained the purpose NASA tried to achieve with the Golden Records. He stated the reasons for the Golden Records creation to answer questions that we would have. He elaborated further that the Golden Record is like a self-portrait of everything here on Earth. It would answer all of the questions to be asked by any alien who discovers the space probes. He also pointed out that the records are not designed to prelude first contact in searching for extraterrestrial intelligence. The Golden Records might be found millions of years from now, perhaps when human civilization no longer exists. At that time, it would be more like finding a fossil. It would serve as a memento that we were once here, just like the way we discovered dinosaurs. The Voyager probes were preceded by the Pioneer missions. The Pioneer missions carried small metal plaques with symbolic messages. Although the Pioneer systems are no longer functioning, no other space mission has incorporated a similar record of humanity since then. NASA's New Horizons tried to offer another chance to Pioneer systems when it flew by Pluto in 2015. When scientific artist Lomberg was asked about the incident, he said it was a missed opportunity. He proposed another suggestion, though, that it might still be possible to send a digital message to the spacecraft's computer. That would be durable, but it would not last as long as the Golden Records. Each of the Voyager Golden Records consists of 115 analog encoded photographs, greetings in 55 different languages, and a 12-minute montage of different sounds of the Earth. Also, these space probes carry 90 minutes of music on this Voyager Golden Record, but these are not the only things on the record. The team that put it together felt it was important to convey informally about human anatomy, so they drew diagrams from the 1978 edition of the World Book Encyclopedia. NASA also included the silhouette of a male and a pregnant female. So much for the Golden Record being our self-portrait after all. As they tried to explain reproduction, NASA approved a drawing of the human organs and images that explain the concept of childbirth. The photo used to depict childbirth by NASA was the famous photograph of Wayne F. Miller's son. In addition, NASA and the Golden Record experts then picked silhouettes of the two figures, a male and a female, and a fetus positioned within the woman's womb. The photo was featured in Edward Steichen's 1955 Family of Men exhibition. The National Aeronautics and Space Administration also added details about how we humans live, such as a demonstration of us eating, licking, and drinking. When producers had issues getting a specific image in picture libraries from different organizations, NASA and the Golden Record experts had to create a version for the Golden Record. They tried to explain the mouth's functions, for which they had an odd but informative picture of a woman licking and savoring an ice cream cone. There is also a photograph of a man taking a huge bite out of a sandwich and a thirsty-looking man drinking water in huge gulps from a jug. But information about the human body was not the only form of pictures uploaded on the Golden Records. Some images were chosen based on the record they've set, not based on aesthetics, but on the amount of information they pass along and the clarity that comes along with the image. It seems strange that a pictorial illustration of Olympic sprinters was among the information compiled into the Golden Records. However, it is one of the most explanatory photographs that made the cut. This is because the photograph shows several races of humans, explains the muscular nature of the human leg, and how it is used as a form of competition and entertainment. However, informational photos were not the only pieces of information that made up the Golden Record. The team responsible for details in the Golden Records added artifacts such as the Taj Mahal. This is because photographs of huts, houses, and cityscapes were included in the Golden Record, so it would serve as an overview of the types of buildings constructed here on Earth. And for this purpose, the Taj Mahal was chosen as an example of very impressive architecture. This sounds baffling compared to the other types of buildings and monuments. However, the Taj Mahal was picked over huge definition buildings like cathedrals, Mayan pyramids, and other structures. This is because Mughal Emperor Shah Jahan built the Taj Mahal in honor of his late wife Mumtaz Mahal and not for a god. In the Golden Records, 3/4 of the disc were devoted to music and sounds of all kinds, so visual art was not exactly a priority to the team that put it all together. Despite that, some photographs taken by the iconic photographer Ansel Adams were selected to be included in the Golden Records. They were selected not just because of the photographs themselves, but for the details captured within their frames. One such image is the Golden Gate Bridge from nearby Baker Beach. The image was chosen because it was thought to clearly show how a suspension bridge connected two pieces of land separated by water. The sound of an automobile was also included in the record's sound montage, but the producers could not overlay the sounds and images. The Voyager spacecraft have created a beautiful influence on space exploration since its first discovery. Their success inspired NASA and other agencies to visit other planets again. Planets like Jupiter, Saturn, and their myriad of moons were visited again and again and studied. These missions featured Galileo, Juno, Cassini, and the European Space Agency's Huygens lander. New probes were also added to the subsequent missions, such as the Europa Clipper, Dragonfly, ESA's JUICE, and potential voyages to Uranus and Saturn's moon Enceladus. The interstellar spacecraft did not just have a huge influence on space exploration, but also influenced pop culture. The first Star Trek movie in 1979 featured an alien called Voyager, which is actually an altered fictional Voyager 6. The Voyager spacecraft and golden records have also been discussed in TV shows like Saturday Night Live, The West Wing, and the one we all know, The X-Files. The composer Dario Marianelli even wrote a Voyager-inspired violin concerto. Scientists believe the Voyager spacecraft might stop working this decade, after 45 years of service and giving scientists the biggest discoveries ever known to mankind. It is known as a gift to science, which would keep on giving till the very last moment, and hopefully we get to discover a lot more before that time comes. Let us know your thoughts in the comments section below.